Welcome to the Retro Hack Shack. In the spirit of the Star Wars Holiday Special, I'm calling this my 2020 Holiday Special. Hopefully it won't be quite as campy, though, as that. I just want to thank everybody for subscribing. It was kind of funny the other day. If you're familiar with the little trophies or whatever they are that YouTube sends out when you get to 100,000 subscribers or 500,000, I'm not sure what the numbers are. They sent me a little animated GIF for reaching 500 subscribers. So for all those who have already subscribed, thank you very much. I'll show you that animated GIF here in the video. I thought it was just kind of funny that they would send that. Maybe a little insensitive during the pandemic, as not that many people are flying, but it's a little animated GIF of people boarding a plane and going somewhere. So now I am planning a special episode when I hit 1,000 subscribers. I'm not going to give away what it is right now, but you're really going to love it. So as soon as I hit 1,000 subscribers, or shortly after I hit 1,000 subscribers, there's going to be a special episode. Well, I'm not going to tell you what it is. When I get to 1,000, you'll just have to see. Recently, I came across a bunch of modems, and this was part of a big box of stuff that included power supplies and an MFM hard drive. And I got this for cheap because the guy said if you come take it, you have to take the whole box. Basically, he didn't want to get rid of a lot of the stuff that was in it. So I took the whole thing and I ended up with, like, I don't know, 14, 15 modems that I really didn't know what to do with. At the same time, it is the holiday season and we're putting ornaments up on the tree. And I thought maybe I could take one of the smaller modems and turn it into an ornament. Now, I've got a couple of ornaments on the tree already that I love from Star Trek. One is Star Trek Shuttle Galileo, which is kind of cool.
Shuttlecraft to Enterprise. Shuttlecraft to Enterprise. Spock here. Happy holidays. Live long and prosper.
And the other one is Captain Picard and Data, who go back and forth every time you press a button. There's a little saying that comes from The Next Generation.
Data, find a way to defeat that shield. That may be impossible, sir. Things are only impossible until they're not. Yes, sir.
So in looking at this Zoom modem, which is kind of small, I thought maybe I can take that and create an ornament out of it to fit under the tree. So that's what I'm going to do, and it's coming up right now on the Retro Hack Shack. All right, so here is the Zoom Model 470. As you can see, it's got an array of LEDs on the front, similar to that other modem that I worked with. I was trying to look up the speed for this, and I found a picture of the box, which lists it as a 28K modem, 28.8. And it also has a little light here for 14.4, so I'm assuming this would perhaps auto-negotiate down to 14.4, and if it did, maybe it would light up that light. Interestingly, if you want to know what all of these lights mean back in the day, of course, they would just print them on the back here. And so you can see 14.4 here, 14,400 bits per second, and it says that means that the modem is communicating at that speed. So there you go. This is listed as a V.34x compliant modem, but I just don't remember all of the things. I never understood them back in the day. I just knew, that number would go up, and I think by the time we got to 56K modems, it was like V.92 or something like that. Anyway, I just remember, the more that number goes up, the better. And I'm sure people that understood that modem technology and communications technology back in the day probably know exactly what those numbers mean. But anyway, that's not what we're here to discuss. I just wanted to take a look at this modem before we get started. Here is the back here, and it's got a barrel jack for 9 volts. If you wanted to use this as a modem, 9 volts DC. It's got a serial port here to communicate to your computer, and it's got 2 modem jacks. So there's one that goes to the modem and another one that passes through to your telephone. So another thing I might do with one of these, I was thinking might be interesting, is to take the guts out essentially and put in a ESP32 microcontroller which you can rig to, and I've got a couple of those around. I made my own PCB for them. Oh, here they are. Actually right here in a bag. So I made my own PCB for these modems, which have some options, and they take USB power, I believe, and you can connect this, and then it will connect to the internet. So pretty cool. Anyway, so what I thought I would do maybe on a future video is put one of those in here, and that way you can still connect the serial up to an old computer, but it will actually connect to your Wi-Fi instead. And you can use this device as kind of a cool retro looking way to connect that to your computer. So watch for that in a future episode, perhaps. So for now, let's start turning this thing in. Oh, you know, another thing I realized when I was looking online is that what made me think of this in the first place really was the fact that some of these LEDs light up green and some of them light up red. And that's what got me thinking about turning this into a ornament, because it has the green and red for Christmas colors, typical Christmas colors. So that's what got me going on it. And I've got a picture of that as well. So let's go ahead and break this open. It's definitely going to need some cleanup at the end to get these stickers off. There's some sticky goo here on the bottom. That's really sticky. But let's go ahead and open up this case and take a look at what's inside. And there's 2 screws on the back here as well. There we go. It opens up pretty nicely. There's a look at the inside. I'm not sure if I can get the cover, this RF shield, off. It appears to be soldered onto the board. Otherwise, it's interesting that there's not a lot of surface mount stuff in here. It's mostly through-hole. Everything I can see is through-hole componentry here. So that's pretty interesting. This switch will come in handy for switching the power on and off for the ornament, or perhaps for triggering a sound that we can use. And there is a speaker here, so maybe we can tap into that speaker like we did with the other modem and use that to play some music. And if I hit the button here, you can see we get the sound effect as well. Hopefully you can hear that. There's also a fuse back here that could come in handy. Some transformers. Pretty simple. Let me see if I can take off this RF shield real quick, and we'll see what's under there. So taking a look at this board, luckily these aren't even soldered, these little tabs that are holding that RF shield in place. So all I need to do is grab a pair of needle nose and straighten those out, and we should be able to pop that off. Whoop. Yeah, that came right off without even trying. So there we go. That's a look at what's inside this thing. So you can see there's a couple of chips here. A Rockwell 95 chip. Looks like date code 96, fifth week 96 probably. And another Rockwell chip here this is Rockwell 93. And I'm looking for a date code. You can probably see it on the, oh, here it is. I think this is it here. Can barely see that because of the way the reflection is, but it looks like the 7th week of 96 for that Rockwell 93 chip. So there you go. If you're into modems and you know what those chips do, I do not. This definitely looks like a firmware chip, though, some sort of a ROM with the firmware on it that runs the software for the modem. Let's get in here, take a look at the back too, because here's all those LEDs. Like I said, there's a nice mixture here of red and green LEDs, just perfect for Christmas. So my thought was I could do something simple and just blink these on and off in alternating pattern here. So red, green. And that looks to be pretty easy because all of these are just soldered in. So again, if I just connect the wires there, it's almost tempting to cut off this front part of the board because this is heavy. And I've got a number of these. So I hate to cut anything up, but at the same time, this is really heavy and I don't need all of it for the ornament. All I need is probably the barrel jack and the LEDs. And I think that's it. Oh, and the speaker as well. So, Nah, I can't do it. I can't bring myself to get out the Dremel and cut into it. I was thinking I could cut right along here and basically cut out all of this weight that's in the middle here, but I just can't bring myself to do it. I don't know. Maybe I'll want to do something with this. Maybe it'll be worth something someday or something. So I think I can just mod it in place, and then I can always back out the modifications if I ever want to go back. It's going to make it really heavy. I'll have to find a really sturdy branch to hang this from, but that's okay. I hate destroying old technology. Now, for the sake of time, I'm going to skip ahead in this video, and I'm just going to do the same technique that I used on that other modem that I turned into a Knight Rider modem. It was a courier modem that kind of had a Knight Rider feel to it. So if you want to see exactly how I go about doing this and my thinking behind it and what I did, go take a look at that video. I'll link it up above. But for this, I'm just going to skip ahead. I'll do all the wiring, get everything set up, and just go over it briefly, and then we can see if it works. And one of the things I wanted to do was to test out these LEDs to see if they work real quick. And you can see, I think you can see anyway, I'll try to zoom in a little closer on this. But you can see through this LED because it's fairly clear. There's two parts to the LED, and one of them has a longer part, and then there's a line, and then there's a shorter part. That longer part should be the cathode end of the LED, or the negative side, and this anode should be the other part should be the anode side or the positive side. So that can tell you if there's not a mark on the LED. There's also should be a flat side here on the LED, which indicates the negative side, although that's not always 100% accurate. So, but just looking at the LED, you can kind of tell this side here is the cathode side and this side here is the anode side. So then by using a coin cell, I can actually hook up, we said that this side was the cathode, and on this coin cell, this back side is negative and the top is positive. So I can kind of like get this in here and see if this works. Yep. Sure enough, that LED comes up, and then I can go through really quickly and just carefully by touching these, I can see which ones are working. This red one, yeah, it's working. And so there you go. You can just quickly go through and test all of these in circuit with a coin cell like this, once you know what side is positive and what side's negative, and test and make sure they're all working. Pretty cool. And they all work. And just like with strings of Christmas lights where you have to check every bulb.
You have to check every bulb. Oops, a little knot here. Look at that. I'll get you the box.
I went ahead and tinned every connection on every wire that I was using. It does make the solder joints a little bit more reliable and makes it easier to connect the wires to the joints themselves. Okay, so through the magic of YouTube, we are back and everything is connected and I'm ready to run a test. Now I should say that I wanted to go over a couple of the differences that were in this project versus my Knight Rider modem hack that I did before. One of the things that's different is instead of needing to individually control every LED on this particular board, I only needed to control the green, have the green come on at one point and have the red come on at another point. And that's what you can see in these wires here. What that means is I was able to take these wires and connect them in such a way that they all go down and get combined. I don't know if you can see that, and go into the board. So instead of having to address every LED individually, I was able to combine them and reduce the number of digital pins I needed to use on the Arduino by physically combining those into a single connection into the board. So I've got one for red, one for green. Now, if you had more LEDs than this, more than 10 or 20 LEDs that you needed to run, you're probably not going to be able to put that much current out of an Arduino. So keep that in mind if you want to build a project like this and you want to combine LEDs into a single digital pin. Those digital pins do have limits in terms of how much current they can put out, and you can look those up depending on what board you're using. So something to keep in mind there. The other thing that I ran into was when I hooked these up, there were two pins or two chips here, two ICs connected that were responsible for turning these LEDs on and off. And what I found was that those were actually getting in the way. They were chips that were flip-flopping the signal, and so they were turning different LEDs on at different times because I was actually powering those up via the USB power that was coming in through the Arduino. I was actually powering those chips up, and they were causing weird things to happen. So what I did was I removed those two ICs and saved them for later if I ever want to use them for something else. And that gave me a really nice place to connect the wires that I needed to for each of these groups of LEDs here. So that was one thing. The other thing I did was I tried to use this built-in speaker, but it just really wasn't loud enough. So I opted for another speaker. This is just a little hobby speaker, but it is loud enough. So I'll be placing this inside the project, and it's going to be a lot louder than the one on the board. Plus, when I connected to that speaker on the board, the way that this was connected, it was causing this yellow LED, which I decided to put here for power. Yeah, yellow's kind of a Christmas color, right? I don't know. Anyway, this yellow LED was, the green LED that was here was bad, and so I replaced it with a yellow one. But when I would play the music through the built-in speaker, it was causing this LED to dim and do strange things. So again, you need to be careful of the board itself and the components that are on this board, and the way things are connected together may cause you trouble if you're trying to do a hack like this to a board in the future. So keep in mind, whatever's on the board, if you're going to keep that, it may wreak havoc to what you're trying to do depending on how things are connected. The last thing that I wanted to point out, well, two things really. One is the power switch. So I wanted to get power directly from the barrel jack that was on the board. And while that's all fine and good, I inadvertently, when I hit when I turned this on for the first time to try it to play a sound, I actually blew the fuse because I forgot that this was the power switch. It was actually connected to the the positive voltage, the middle barrel jack, the middle part of the barrel jack was connected here to the switch. And so when I turned that on, I connected some things that shouldn't have been connected, and I end up blowing that fuse out. So once I figured that out, I made a big cut through those traces that are coming from the barrel jack to this switch. So now this switch is just standalone, and I've connected to that switch with a couple of wires here that go back to the Arduino. So I shouldn't get a short circuit anymore from that. Last thing I wanted to mention is this took a little bit longer than I expected because I had several of these little MP3 music player modules that you can buy that I use in a lot of my projects. And I had 3 of them and I couldn't get any of them to work. They were all bad for one reason or another. Perhaps I had connected them wrong in the past or blown something out. I don't know. But I ran out of those, and so I ordered some more from Amazon, and they came in a couple of days, and then I was able to finish this up, and now it appears to be working. So I'm going to plug this in. It should, as soon as I plug it in, it should go ahead and play the modem sound and start blinking the LEDs. There we go. Lights are blinking. And I don't know if you can hear that, but there's the modem sound. So things are working. What happens is it plays the first time you power it up, it plays, and then if I press the switch, so at any time you can walk over to your Christmas tree or whatever this is hanging, you can press that and it'll start playing the sound again. So that's kind of cool. Everything seems to be working at this point. Let's take a quick look at the code and see how I program this up. All right, so here's the code for the Arduino, and I will put this up on the website. If I forget, please remind me in the YouTube comments, and I'll make sure to do that. But the code is pretty simple. Up here we've got a listing of the various variables that we're using, and you can see there is a timer, which actually I don't need anymore, so I can take that out. I don't think I'm using the timer, am I? Oh yeah, I am using it, sorry. So there's a timer. This is the seconds in milliseconds that we're going to change those lights out. Basically every 500 milliseconds or half a second, we will change those lights from red to green and back again. And then I have the pins for that the the wires are connected to that go to the various LEDs. So the green LEDs are connected to pin 8, red LEDs are connected to pin 7, that yellow LED is connected to pin 6 because there were some issues with that LED when I used it together with the green. I had it initially together with green, and there was some weird issues there, so I just separated it out. It could have been drawing too much power. And then I have another digital pin that is connected to the button on board, and there is the last pin, pin 4, is actually connected to the sound module. So what that does is it pulls the one of the pins on the sound module low, and that actually plays the song. I'm also keeping track of the current time with the millis function, and there's a Boolean variable here so that I know, did I just turn the green LEDs on or did I just turn the red LEDs on? I'll show you how that works in a second. And then I'm also keeping track of that button state, because the button is not a momentary button like it was on the other modem I worked on. This is actually a switch, so it's either on or off. And I still wanted to be able to use that switch to trigger the music, or in this case the modem sound, to trigger that to play. And it's like, okay, well, if the button's on and I turn it off, I want it to play, as well as the other way around. So what I did was I figured out a way to toggle that so that it will work. Instead of being triggered only when the button is on, it'll actually look for the state of that button, and it'll say, does the state of that button change? So in other words, if it's off and goes to on, I'll play the sound. If it's on and goes to off, I'll play the sound. And that's the way you can handle switches versus momentary buttons when you're working on a project like this. And then in the setup here, we're just setting the state of those particular pins to be either inputs or outputs. And then I also turn that yellow LED on immediately on power up, because it is a power LED, and I wanted that to come on right away. Down here in the loop, we're actually, I'm using that timer function, that 500 millisecond timer, along with the what I call previous time, which uses the millis function. So if you're not aware, millis, sorry, that was my phone. If you're not aware, millis basically gets the number of milliseconds since the device has been powered up. And so I'm comparing those two basically to say, you know, if the time right now is, if the time right now minus the last time I checked what time it was is greater than 500 milliseconds. So kind of a long way of going about this, but it does work pretty well. Then do this function. The reason it's important to have a function like this is because if you just use delay, like an easy way that people do this when they're first starting out is they'll, for example, turn the green LEDs on and they'll put in a delay function. But that delay function keeps the program from executing until that delay is done. It basically puts a hold on everything else going on, and you can't execute anything, like, for example, to figure out whether that button has been pressed to play the sound. You wouldn't be able to do that during a delay. So this way, every time this loop goes around, we're just checking to see, is it time to run this thing yet? If yes, run it. If not, then go on with the rest of the program. So it's a much better way of keeping resources free on the Arduino than using the delay command. So that's why I'm doing it that way. And then if it is more than 500 milliseconds, here's where that Boolean comes in. So if that Boolean is true, which means that the green LEDs are on, then I basically, down here, I turn the red LEDs on instead by bringing them low in this case. And then I update that Boolean. And I also update the timer that we're using so that it starts counting again. Now, if the green on Boolean is actually false, meaning the green is not on, meaning the red is on, then I go ahead and turn the green LEDs on and flip that Boolean to true again. So the next time it goes around, it'll go and turn the reds on after that little timer expires. So that's the program. It's only a few lines of code, but it's doing a lot right there with logic. And then this other part of the main loop here is actually just examining the state of that button that I mentioned before. And it is, if it sees that the state has changed, meaning the button is either on or off when it used to be the other way, then it will actually take that digital pin and set it to low, which plays the sound. In this case, it will wait for about 100 milliseconds. It's not very long. Nothing else is really happening in 100 milliseconds that I have to worry about. So I am using a delay there. And the delay is just long enough to be able, for the sound module to be able to recognize that it has been grounded, that pin has been grounded, so it will actually play the sound. And then after 100 milliseconds, I turn it back high again, because that's the normal state that I want it to be in, unless that button is pressed. And that's it. That's all of the program. So it's just 44 lines of code. I hope that all made sense. It does in my logic, at least in my brain. This makes sense. There's a whole lot more we could go into in terms of programming, but I wanted to just show you what the program does and how it works. That way, if you wanted to use it in a project, you could download this and modify it to your heart's content. And I'll also add some comments up here before I upload it to the website so that people can see what these variables are and things like that. Okay, so with everything working, the only thing left to do is to use some Kapton tape and some sticky adhesive tape to secure the boards down to this modem board and make sure the wires are all tacked down so they don't get loose and get in the way of screws and other things. And the Zoom modem ornament is now up on the tree. Let's take a look. This project was a lot of fun. Of course, the Zoom modem is quite a big, heavy ornament, so I'm not sure I'll leave it on the tree. But it was kind of fun just to see if I could do it, play around with some old technology, and just have some fun hacking on some old equipment that certainly I remember in my early days of using computers, really enjoying hearing those modem sounds as you connected to America Online or CompuServe, for example. So it's just kind of funny, something funny to put on the tree, and it's fun to play around with old technology like that. I hope you enjoyed the episode. To close this out, I'm going to be playing some Christmas demos from the TRS-80 color computer. So with that, I hope you enjoy. Thanks for liking these videos, subscribing to these videos, signing up on Patreon. It's been really great to talk to everybody in the comments and learn what kind of things that people are working on and what they like about the various episodes I've created. So please keep that up. Be sure to subscribe, and we'll see you next year. Thanks for watching.